Hey, this is Charles with Rocky Mountain ATV MC. Today I'm going to show you how to clean and inspect the engine parts on your Polaris RZR 900. You're watching part 3 of our engine rebuild series for the RZR 900. We've already got this thing torn apart, so we need to clean everything up and inspect it so we know what parts we need to replace. We will be doing a separate video on the cylinder head, so be sure to check that out if that's what you need. But let's go ahead and get into this. To do this job, we've got our dial indicator, some V-blocks, micrometers, snap gauges, we've got a straight edge. We also need gasket scrapers, and we'll follow that up with a little bit of Scotch-Brite. We've got some pipe cleaners, a hone, as well as a brush to clean up after we're done honing. You'll need safety glasses, rags, some rubber gloves. We also have some light oil for the hone and some contact cleaner. To get all these parts inspected, we need to clean them up. So most of these parts, I'm going to be spraying contact cleaner on them and getting all the oil off. And then all of the gasket surfaces, we're going to scrape the gasket and clean that up as well. As you're scraping the old gasket material, be careful not to damage your sealing surfaces. And then again on the case halves, there's going to be some oil passageways, and we're going to spray through those and make sure they're free and clear. Now that we have all of the engine parts cleaned up, we're going to start things off with a visual inspection, and that kind of eliminates common problems. So a few common issues that happen, or reasons that you'd be tearing this engine apart: you could have some bottom end noises like a rod knock, or like us, what we had, we were burning oil. So we're going to pay special attention to the cylinders, piston and rings, as well as the valve guides and valve stem seals, or valve guide seals. And the other thing that can happen, maybe you just had valve train problems. So if you had problems with the valves or cylinder head, again, we're going to cover that in a separate video. But for now, let's go ahead and visually inspect all the parts we have laid out on the bench. All right, to start things off, we'll be checking these intake boots. We just want to check and make sure there's no cracks. If they are, we'll want to replace them. On ours, this O-ring on the bottom, it's looking pretty bad. So we'll definitely want to replace that. Now, moving on to the cylinder, this is a Nika seal, and it's just a thin coating for the piston to ride on. If it's worn through, you're going to see aluminum on the other side. Now, a lot of times how to tell if this is worn out, what you'll do is take your finger and run it across. If you feel any grooving or your fingernail catches on anything, then you're going to need to get the cylinder replated or replace it. So moving on to the stator cover, if you do need to know how to test this stator, we do have a separate video on that, but for us, we're just checking, making sure this gasket sealing surface is smooth and not damaged. And we've got a bearing right here. We want to rotate that with our finger. And if it feels notchy or rough in any way, you want to replace it. Now, if these cam chain guides are worn out, you're going to see grooves from the cam chain worn into them. Moving on, we have a one-way clutch right here, and it should spin freely in the clockwise position if everything's laid out like that, and it should stop immediately if you try to go counterclockwise with it. This oil pump, if you had lack of lubrication, this might be suspect. For us, we're just making sure that the sprocket teeth are in good condition. And then again, you got these tabs on the back side. You want to make sure that these don't look like they're worn down and about to break off. From there, pretty much what you're looking for on a lot of these parts is just checking sealing surfaces and making sure you're not going to have any leaks. Next, we'll inspect any parts that come in contact with each other, like something that has a bushing or your camshaft journals to cam bore. And what you're going to do is check for any pitting. You can run your fingernail across the surface, check for scoring, or you might even see some galling, which means that some material has transferred from one part to another, and if that's happened, then you know those parts are bad. Moving on, we'll inspect all of our parts that have gears or teeth on them, and what we're looking for here is that none of the teeth are broken off or rounded. And then a lot of times what happens with these parts, one side of the tooth gets more wear on it than the other. So if the pattern doesn't look uniform on the tooth, then you know it's bad and needs to be replaced. Now that we have our visual inspection done, we can now start the inspection process. So to do that, we're going to start with the crankshaft. Now, as we go through this, these crankshafts, these journals right here can actually be different sizes, and there's a code printed into the side of one of these webs right here. It's just a 6-number code. Ours is all the same, it's all G's. So we're going to reference that a little bit later on, and that's going to give us the specs, what these journal diameters should be. So we're going to go ahead and measure these journal diameters. Now, starting right here on the magneto side, we're going to have our number 1 journal, and then it just goes sequentially to number 6 on the PTO side. So as I go through, I'm going to measure one way and then take another measurement 90 degrees from that, and we'll go all the way down and compare those measurements to spec. All right, now that we have these measurements taken, you can see on 5 and 6, there is a little bit of variance, but we're measuring to the 4th decimal place, so that's 1/10 of a thousandth of an inch, and that difference isn't even going to matter. So we're now ready to take these measurements and compare them to the spec in the book. We've compared our crankshaft journal numbers to the specs given in the book, and all of our measurements are right on the money. Another measurement we can do on this crankshaft is the runout. So to do that, the manual wants us to have our V-blocks right here on these 2 crankshaft journals and take our measurement on this PTO side right here. And something to keep in mind, this is tapered, so you want to make sure that the crankshaft isn't moving back and forth, because that's going to skew your measurement. So I have this backed up to where I can lightly pull on the crankshaft while I rotate it, and it's not going to go back and forth. So, and when I take this measurement, I'm going to go 2 revolutions and see how far this needle goes, and our limit is 1/1000th of an inch. Now our crankshaft is within the service limits, so we will be reusing this, but if your measurement shows that your crankshaft is out of spec, or you suspect you're getting a bad reading, you can move that dial indicator over to the nearest machine surface, and that way you can verify whether or not you're getting a good reading on that indicator. After that, we'll measure the journals of the counterbalancer shaft. The next thing we want to do is take some measurements on our connecting rods. Before we do that, I want to point out just a couple things. So on the connecting rod cap, I actually have a number here that matches with a number that's on the connecting rod. That way you make sure you get the right cap to the right rod. And then on the other side, just on the cap, there's a number stamped into it. And that number is going to help you determine which plain bearing to use. And you'll use that in conjunction with the numbers on your crankshaft. So what we'll do now, I'm going to put the connecting rod in some soft jaws, and then I'm going to take these old rod bolts. We're going to use new ones on reassembly. We're going to torque these to 13 foot-pounds, and that way we can measure the ID of the rod big end. Now I'm going to use a snap gauge to measure the small end ID, both vertical and then 90 degrees from there. So now that we've compared the small end measurements to spec, we know they're right within specification, and we'll move on to the big end. Now, these big ends, these are going to be a different size. So you're going to refer, ours has a number 2 right here, so we're going to refer to the chart with a 2. If yours has a different number, you'll refer to that chart. Now moving on to the cylinders, a couple things I wanted to point out. We need to finish cleaning this up, and to clean this build up at the top of the cylinder, I'm just going to use a little bit of Scotch-Brite and go in the same direction as the crosshatch pattern. Or you could also hone the cylinder. Not only will this remove the carbon ring, but it's also going to remove any glazing and restore the crosshatch pattern. Now, if you're not familiar with this process, you want to refer to our cylinder honing video. I do want to point out that Polaris recommends against this, but if you choose to do it, just make sure you're using a hone that's specifically made for Nikasil. All right, now we'll take our straight edge. We're going to measure the cylinder for any warpage, and to do that, we'll lay the straight edge straight across and then diagonally in both directions. And we've got our filler gauge set to the service limit, which is 2/1000 of an inch, and we'll see if that slides under at any point where the straight edge contacts the cylinder. If you take any measurements that exceed the service limit, then you'll need to replace the cylinders. Next, we'll do the X and Y measurements for our cylinders, and we're going to do them in 3 spots. So we'll do them at the top, middle, bottom. So we'll do one going down that way, and then top, middle, bottom on both cylinders. One thing I want to point out, if you do have access to a dial bore gauge, this is going to be a little bit easier to take all these measurements and a lot quicker. But the snap gauge still works fine. We've got all our measurements, and each individual measurement falls within spec. But now we need to compare them to each other. So we need to find out if we have any taper from top to bottom in either of these cylinders. The limit for that is 1/1000 of an inch. So you're going to compare all the way down. If it varies more than 1/1000 of an inch, you know you're out of spec. And then the other thing, you want to measure your outer round. So if you measure your X measurement and compare it to the Y measurement, and there's more than 1/1000 of an inch variance between those two, you know you're out of round, and you'll need to take care of that and either get these cylinders replated, or you can replace them as a complete unit. Same, if any of those measurements are out of spec, you'll need to have this repaired or replaced. All right, so 9 times out of 10, you're going to be putting a brand new piston kit if you have the engine apart already. The only exception, if you had some kind of trouble with the bottom end and you need to get that fixed and these pistons still look brand new, then we'll show you how to measure this stuff. So just starting with the wrist pin or piston pin, whatever you like to call it, we're going to take 3 measurements, and then we'll do the same thing 90 degrees and compare those to spec. All right, for this piston outside diameter, we're going to mark 10 millimeters down from the bottom of the piston, and then we're going to take our measurement from there. The other thing with this, once you have the piston OD, you can subtract this measurement from the cylinder ID, and then that's going to give you your piston to cylinder wall clearance. Now again, if you are reusing your piston, you're going to want to measure this bore right here where the piston pin goes. So to do that, we're using a snap gauge and micrometer. And now we'll take that same measurement on the other side of the piston. All right, at this point, we're now ready to measure the ring end gaps, and you definitely want to take this measurement whether you're reusing your old stuff or using new parts. So to do that, our manual tells us to measure the ring end gaps 15 millimeters from the top of the cylinder bore. So that's going to be this ring land right here for the oil ring. Pretty much pass all this stuff and get to that very corner, and then we'll check the gap with a feeler gauge. And this one, our manual actually gives us a spec for the oil rings too. A lot of times you don't have to worry about those, but since the manual gives us a spec, we're going to check it. All right, if you're using brand new rings, you want to make sure you have at least the minimum gap. And if you're using old rings, you want to make sure you don't exceed the service limit. So we're just going to use this minimum amount feeler gauge, and that fits in really easy. So we know we're good. We got a brand new ring, and we'll do the other one as well. So if this end gap was out of spec, what you can do is put a file into your vise and then just run this the way the file would normally cut. So we'll just run it along there, and you'll do that until it's within specification. Now the last measurement for these piston rings and piston that we'll do, again, it's for used parts. If you're going to see if you could reuse them or not, we'll measure the clearance between the piston rings and the piston. So I just went ahead and I went straight to the service limit, and we'll make sure this doesn't fit in between the piston ring and piston. And ours doesn't, so we know we're good to go. Now, if any of the measurements that you just took do not fall within specification, then you'll need to repair or replace those components. And now you'll go ahead and do all of the same measurements for the second piston and cylinder parts. All right, now that we have all of our parts cleaned and inspected, we'll take our parts list and get everything that we need. Don't forget, we're also using new O-rings and gaskets for everything, so that's something you definitely want to do. And if you need any of these parts, check out our website. We have a lot of different options on there. Now, we are doing a separate video on the cylinder head and valve train components, as we mentioned earlier, so be sure to check that out. And don't forget to subscribe to our YouTube channel because we have a lot of other helpful videos on there. That's it for today's video. Thanks for watching.